We have our fifth and final presentation. It's going to be with electronic grid systems. And we have Zonji, and he is going to do his presentation. So enjoy.
Yeah, thanks, Dan. Let me just pull up my slides.
Take your time.
Yeah, and it's very good to know that we have a pretty diverse group of technologies in today's presentation. And good morning, everyone. My name is Zhongyi Kwang, and I am the founder and CEO of Electronic Grid Systems. And so we're a startup based in Edmonton, and we're developing an intelligent and scalable EV charging solution that to help you build EV charging stations with lower cost. And yeah, what's this? Sorry, just give me a second. Yeah, so I'm sure that all the audience here today have ambitious sustainability goals, and I believe that EV and EV charging will be part of your plan, if not already, because switching to EVs or deploying EV chargers not only reduces the emissions but also brings lots of other benefits like attracting more customers, providing benefits and services to employees, reducing vehicle costs, gaining additional revenues, and many more. But like many other goals, it's not easy to make this transition, and I'll tell you why. So I'll start from how EV charging stations are built, and because this is a fairly new space for the audience, I believe. So many people think that EV charging is simple, like we can simply plug in a charger and then the energy will flow through the charger and be filled into the battery, and that's done. But unfortunately, it's not that simple because the elephant in the room is the power grid, and our power grid was not designed to handle the EV charging power demand. So the reason is that with more and more EVs on the road, the charging demand will increase the power demand by 40% in less than 20 years. And then in order to have all the EVs being able to charge, we need to spend trillions of dollars to upgrade our existing grid infrastructure. And that inevitably brings lots of problems for people who want to install EV chargers. For example, before EV chargers can be installed, the electrical infrastructures like transformers on customers' locations need to be upgraded. And for instance, for Suncor, when Suncor deployed their chargers at 55 of their locations, only one location had enough capacity. So they had to ask utility companies to come in and install new transformers for them. And that was very time consuming and expensive. And in addition to that, EV charging also results in high power demand. That's much higher than it used to be. And the result will be a very expensive peak demand charge. And more importantly, with today's charging solutions, it's almost impossible to expand the charging station in the future. Because if you want to install more chargers in the future, you need to upgrade the infrastructures again. And that is also very expensive and time consuming. And we've talked with many potential customers, and we found that all these problems have been the major barriers for them to adopt EVs or build EV charging stations to make the transition. So what we do is we develop a microgrid technology, microcharging technology that can debottleneck the existing grid infrastructure and perfectly addresses these problems. So our technology integrates three pieces: advanced power conversion for microgrid systems, intelligent power control, and also energy storage. So what we do is we control the EV charging power through the cloud or in local firmware to control the EV chargers, to make sure that they operate at the right time and at the right power level, so that the overall peak power will be reduced. And that means you can install more chargers to your existing infrastructures. And also we have an energy storage systems that can be applied in all locations because of our power conversion circuit. And then you can use the batteries to fast charge the car, and then use the grid to slow charge the battery, so that you can shift the demand to a different time where you, like, for example, off-peak time, so that you can reduce the electricity price. So our solution can be applied for both, for either level 2, like the slow charging, or fast charging, or all locations with combined slow and fast charging. And the products we offer are basically three pieces. So we offer a charger management system, that is the cloud service software. And you can use the software to manage the chargers to see what's going on in the charging station. And we have control built into the software. And software is compatible with all the basically all the charger hardware from basically all industry leading manufacturers like Delta, Siemens, ABB, and you can have a mismatch of hardware in the charging station if you like. And we're also developing our own fast charger, and that is first of its kind product in the industry. And for all the applications, our products can avoid that infrastructure upgrades that is required by traditional charging solutions. And in this way, we help you minimize the capital cost and operating cost as well. And on top of that, the solution is future-proof. So that means you can basically install unlimited number of chargers to your existing electrical infrastructure. So if you want to install more chargers in the future, just plug in some chargers with our solution and it's done. So future expansion will not be a problem anymore. And currently we're still developing our fast charger because we're a pretty young startup. We're only 1 year and 1.5 years old, and but our software is ready for market, and we adopt level 2 charger hardware from other manufacturers like Delta, Siemens. So our level 2 charging products ready for market, and we're looking for customers who wants to install chargers for their workspace, whether it's workspace, apartments, car parks, or any other locations. And we adopt a charger as a service model and provide a turnkey service. So basically there will be zero upfront cost from you, and we only take a subscription model, which is well aligned with the operating budget. And right now we're deploying chargers, EV chargers on the campuses of the UFA and NATE. And so if you want to learn more about our projects, our service and products, or our fast charging technology, please feel free to email me. And my name is Zhongyi Kwang. And with that, thank you for your time, and I'm happy to answer any questions.
In fact, there is one question on the Q&A, which is, where does the electricity come from? So presumably it's grid power.
Yeah, I mean, of course it's grid power. So, but what we do is, we shift the peak power to, so you sort of avoid that peak charging power, so that, you actually have sufficient infrastructure on your location. It's just that you cannot handle that peak. And but if we can shift that peak to maybe off peak time, like overnight, and then your infrastructure is, is more than enough to handle many chargers.
Shaving off that peak is actually quite a lucrative business model, because that peak power is very expensive, and if you capture it correctly, you can actually flatten the curve and the peak quite considerably. So this is a really clever innovation. Thank you very much for coming on Energy Innovations. It's been great.
Yeah, thank you.